in some of the examples that you do for homework this week in section 6.5, the directions might say that you can use technology to evaluate the integral. And the reason is because these are so challenging in terms of how much simplification needs to happen and all of this algebra, that they're considering it good enough in some cases to just go ahead and do the setup. So essentially, find the function, take its derivative, square it, plug it into the formula, figure out your limits of integration, and then use technology to actually do the integration. So that is acceptable, and I just wanted to give a quick demo on how to use a TI-84 to do this. Now, this particular calculator isn't required in this course, so you certainly don't need to have one of these, but for those of you who do, if you wanted to shortcut some of your calculations here, especially within the integration, I can show you how to use your calculator. It also really comes in handy when you want to check your integration. So I'm going to go back to the example that I did, which was the very last thing that I had on the first part of the video before it cut off. So I had found my g of y, I had taken its derivative, and I had squared it, and I had plugged it back into my integral. And so without any integration being done by hand, let's take a look at how we can find the answer, the arc length. So on my calculator, I'm going to go to the math function, and then I'm going to scroll down to find the option number 9 on my calculator, FNINT, which means finite or definite integral. And when you select it, you're going to see that it has all the prompts that you need to enter this. So, obviously my lower limit of integration is 0. I'm going to plug that in. On the top, I need a natural log of the square root of 2 plus 1. The only thing tricky, sorry about that. The only thing tricky here is that you do have to watch your parentheses and your square roots and make sure that what's underneath the square root is correct, and use parentheses to define some of that. So now I need to enter this function, and so I can enter it in this form. I can simplify it and enter it. In fact, I could have entered it before I even did the squaring part of the derivative of g of y. So there are lots of different places that you can stop in terms of simplifying. Your calculator can handle it, but I figured I would just use this particular form. So the first thing I need is a square root of a 1 plus a 1/4. The easiest way to enter that is 0.25 of an e to the negative 2y. Now the problem is that in terms of variable options on your calculator, here's where you get your variables, and x is the only option. So although we're integrating in terms of y, the variable is actually arbitrary, so we're going to use x to represent y in our calculators, and as long as our limits of integration are in terms of y, it doesn't really matter. So I'm going to subtract 2, and then I'm going to add e to the 2y, but I'm going to type in x. Now make sure that all of this is still underneath the square root, and I'm going to close a set of parentheses so that the 0.25 is being shown to distribute all the way through that. Okay, now I'm outside of the square root, and I need to tell it what variable to integrate with respect to. And since I've only been able to type x's into my equation, or into my integrand, I should say, then I'm going to have to use x as my variable. And hopefully I get 1, and I do. And so this is the answer that we got when we did all of that work by hand to integrate, and the calculator can find that for us as well.